Good morning, astronomy students. Today I'm going to demonstrate to you the celestial sphere. Here is a model celestial sphere. It looks like a little celestial globe. It has a tiny little sun in it. You can see the little sun. And then it has a little earth inside. So when we are on the earth, we are really inside of the celestial sphere, looking up at the sky. The celestial sphere was invented by the ancients to explain the stars relative to one another and the planets. When you look at the celestial sphere, you will see the celestial North Pole at the top. It corresponds to the Earth North Pole. The celestial South Pole is right on the bottom. The celestial equator corresponds to the Earth equator on the celestial sphere. Now you will see this tiny little yellow ball, that's like the sun, and that is going to move along the ecliptic of the celestial sphere. So when you look at the celestial sphere, remember on the model we are looking at the celestial sphere from the outside. There is a very special point, which is like the origin. It is right here, and it corresponds, it's right here, my finger is right here, the index finger, right at this spot. It's the 0 degrees right ascension, 0 degrees declination. So when you go along, this is like the origin, this point right here. So here you have positive declination. You have negative declination angle. This is like the northern hemisphere, southern hemisphere. Northern hemisphere has positive declination angle. Southern hemisphere has negative declination angle. Now when you go from that special origin point over here, you can see when you're on the outside, you're going to be moving right ascension, the hours. You can also say degrees right ascension or the hours of right ascension. So as you go in this direction, you will have your hours of right ascension. You'll have like 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, and so on. Then when you look at the sun going on the ecliptic of the celestial globe, so we will start the sun at that special point of 0, 0. So here's the 0, 0 point, and the sun is now at 0, 0. Then as the sun moves along the ecliptic, now it's going to go toward summertime. And to get toward summertime, we're going to get to 6 hours of right ascension. And then we're going to be going up to 23 degrees. So let me get there. So here is the summertime from that special point. So here is the summertime. Now you're at you have positive 23 degrees or 23.5 degrees declination, 6 hours right ascension. So that's where we are. Then you continue to move this and you go toward fall, the first day of fall. Now the sun will be at 12 hours right ascension. Notice we're now getting back to the celestial equator. We'll have 0 degrees declination at the first day of fall. Then the sun moves along toward winter. You can see now we are going to be below the celestial equator. We will have negative 23.5 degrees declination, and now we will be at 18 hours of right ascension. Some people will also call it 270 degrees right ascension. Then, of course, we continue the journey of the sun on the celestial sphere. And then we get back to the special point at the spring equinox, vernal equinox of 0, 0. Now the celestial globe works much like longitude and latitude. Declination is like latitude, right ascension is much like longitude on the celestial globe, and you can plot the location of any star on the celestial sphere by using that coordinate system.